You can put the most capable people in a room, give them the budget they requested, the perfect agenda, and the perfect organizational chart. Yet, within an hour, the conversation loops. Decisions stall. The entire system gridlocks, despite flawless infrastructure. When faced with this breakdown, our default response is to treat human networks like machines. We assume a gear is broken, so we add reporting layers, tighten oversight, or enforce stricter policies to force the pieces back into place. But complexity, the sheer quantity and arrangement of parts, does not guarantee stability. Even a densely connected network will collapse under pressure if the components fail to synchronize. Human systems are not mechanical objects. Trying to engineer our way out of gridlock through brute force misses the point. To understand why these systems fracture, we have to look past the organizational chart and examine the actual rules of stability. This is Ilya Prigozhin. His research in thermodynamics showed that order in the natural world emerges through structured energy flow, not rigid containment. Coherence occurs when components integrate through functional alignment. Without that integration, you simply have a pile of complex, isolated parts. In nature, stability arises when energy flows are properly aligned within open systems. It is a product of relationship. This points to a central thesis. Across every scale of the universe, alignment precedes stability. We must learn this structural rule to understand how our own systems survive. Take the basic chemistry of life. Carbon provides the rigid scaffolding for organic structures, but it is inert on its own. Life requires the relational flexibility of hydrogen. Hydrogen bonds function through electrostatic attractions. Individually weak, by continuously maintaining relational alignment, they generate collective stability. This continuous reorganization on picosecond timescales produces the resilient properties of water, allowing biological life to fold proteins, translate DNA, and maintain dynamic internal regulation. At the most fundamental level, matter organizes and stabilizes through aligned dynamic conditions. This pattern extends to the human brain. We often assume that subjective awareness is an emergent byproduct of sheer neural complexity. Gamma-band synchrony reveals that consciousness correlates strictly with distributed integration. Awareness depends on synchronized timing across the brain, rather than isolated neurons. The brain functions as a transceiver, modulating and interpreting signals based on synchronized relationships across different regions. If that synchronized integration breaks down, as it does during general anesthesia, conscious experience fractures. Even our foundational sense of identity depends on relational coherence. We can see this same synchronization when people interact. Using hyperscanning, researchers can record multiple brains simultaneously to see what happens neurologically when teams cooperate. They observe interpersonal physiological synchrony. When a team coordinates on a task, their individual brainwaves and heart rates physically phase align. Trust is a measurable, predictive biological state. When humans interact in a reliable environment, neurological friction drops, freeing up cognitive bandwidth and increasing collaborative speed. In a coherent system, friction serves as a biological diagnostic signal. It points to exactly where a system's relational variables have fallen out of alignment. Effective leadership focuses on stewarding the field. It requires calibrating the conditions of a workspace so that human networks can naturally synchronize. We have built a civilization defined by structural complexity. Supply chains span continents, and digital communication collapses distance instantly. Despite this density of connections, global civilization lacks integration. When a disruption hits, systemic fragmentation propagates across the planet at planetary speed. Our nations, economies, and biospheres are tightly coupled, nested systems. No individual node can survive in isolation from the broader environmental field. We have reached a critical threshold. Our civilizational complexity has exceeded our capacity to survive through competitive fragmentation. Cultural resistance to unity often stems from a fear of ideological uniformity or the erasure of difference. But structural unity requires the integration of distinct parts. Biological ecosystems and neural networks rely on highly differentiated parts. Global stability operates the same way. It requires dynamic, aligned diversity. Planetary citizenship describes the structural recognition of our physical interdependence within Earth's biosphere. From the hydrogen atom to global society, reality does not function like a rigid machine. To stabilize the future, we must move past demanding compliance and start participating in the architecture of coherence.